All right, everyone, let's get started. Welcome to the final technical briefing for Artemis II. As your senior flight engineer, I'm going to walk you through the critical parameters of this mission before we hand things over to the flight director. Make no mistake, what we're about to do is nothing short of historic.
For a long time, that call went unanswered. Well, after a very long absence, humanity is finally picking up the phone.
And just to put this into perspective, it has been over 50 years. 50 years since we sent a crewed mission beyond the relative safety of low Earth orbit. We are pushing out into deep space again, and the significance of that, well, it just can't be overstated.
Okay, here's our agenda. We'll start with the mission green light status. Then we'll cover why this is our final dress rehearsal, look at the critical new deep space systems we're testing, break down the absolute beast that is the re-entry gauntlet, and finally, talk about how this whole mission paves the way for everything that comes next.
So, let's get right to it. The bottom line up front. We are a go for launch. The vehicle is cleared, our crew is ready, and every single station in flight control is reporting nominal. The Flight Readiness Review is 100% complete. And when I say 100%, I mean it. Every single system, from the environmental controls keeping the crew alive, right down to the very molecules of the avcoat material on that heat shield, it's all been verified, it's passed every check, and it is officially signed off for flight.
So just to recap the top-level mission profile, we're talking about Artemis II. It's a 4-astronaut crew inside the Orion spacecraft. Their trajectory is what we call a lunar free return, which is designed to fully stress test this vehicle in the actual deep space environment where it's designed to operate.
Now, this mission, it's so much more than just a historic flyby. It has a critical engineering purpose. Think of it as the final, full-scale, completely integrated dress rehearsal before we even think about committing to landing operations on the lunar surface.
You see, this flight is the final gate we have to pass through. We have to prove, without a shadow of a doubt, that these systems work together exactly as they're designed to, out there, in the real environment. A successful test here gives us the green light and the confidence we need to go for landing operations on the next missions.
Let's get into the hardware, because we are not just flying old tech. A huge part of this flight is testing critical upgrades that we've specifically designed for the brutal radiation and communication challenges of deep space. So let's pose an engineering problem. You're 240,000 miles from home. How in the world do you send back multiple streams of high-definition video and all your critical data? Your standard radio frequencies, they just don't have the juice or the bandwidth. So what's the solution? Lasers. This right here is a paradigm shift. We're moving from radio waves to optical communication. Your old RF systems are power hogs with limited bandwidth. This mission is going to flight qualify a brand new high-speed laser comm system. We're talking the ability to stream 4K video from the moon with way less mass and way less power. It's a game changer.
The secret sauce is the laser communications array. Instead of a wide radio broadcast, it uses a super-focused beam of light. Think of it like a laser pointer versus a floodlight. That concentration of energy gives us a massive, almost geometric increase in the data rate. It's going to give us a level of real-time insight we've never had before.
And it's not just about comms. We've seriously beefed up this vehicle for survival. The crew and the critical electronics are now protected by upgraded radiation shielding to handle galactic cosmic rays and nasty solar events. On top of that, the solar arrays have been redesigned to be tougher, specifically to handle the intense solar storms we're expecting as the sun's activity cycle peaks.
Okay, this brings us to what is, without a doubt, the single most critical, most dangerous test phase of this entire mission: atmospheric re-entry.
If you ask me, what's the one part of this flight that keeps you up at night? My answer is always the same. It's the final 12 minutes.
Lunar orbital re-entry. This is it. This is the ultimate test for Orion's thermal protection system. Everything we've designed, everything we've calculated, it all gets proven right here.
Let's be perfectly clear. This is not a gentle return from the space station. Orion is going to slam into the atmosphere at about 25,000 miles per hour. That's Mach 32. The thermal stress is just unbelievable. The heat shield will hit temperatures close to 5,000 degrees Fahrenheit. This test is the life-critical validation of that shield. There is absolutely no room for error.
A successful re-entry and splashdown, that's what unlocks the next phase of the entire program, Honestly, the success of this flight is the #1 prerequisite for getting the approval to send the next missions to actually land on the lunar surface.
In that next phase, it's already well underway. While we've been focused on getting Orion and the SLS rocket ready, our commercial partners have been working in parallel, developing the landers we'll need to get down to the surface.
We're working with industry leaders like SpaceX and Blue Origin. They're the ones contracted to build and prove out the human landing systems that will meet up with Orion in lunar orbit on the missions that follow this one. This public-private partnership is absolutely essential if we're going to build a sustainable presence on the moon.
And this really gets to the heart of the long-term vision. This isn't Apollo 2.0. We're not just going for a quick visit. The entire Artemis program is being built from the ground up to create a sustainable, long-term human presence on and around the moon. Which really leaves us with one final, pretty profound thought. By proving this technology works, by paving the way for a permanent outpost, are we literally witnessing the very beginning of a sustained human colony on the moon? The whole world is about to find out. For continuing updates on this historic program, make sure you follow CollabGenerate. Thank you.